All right, picking up where we left off, you guys requested number 20, which talks about finding the maximum volume. So again, that's an indication volume is going to be the thing that I take the derivative of. I just got to figure out what my helper is. So a rectangular solid with a square base. I'll do my best to draw a square base. That should be a solid line. Oh no. Let's start that over. There we go. That's looking a little better. Maybe not, but doing what I can. All right. Has a surface area of 337.5 square centimeters. Find the dimensions that will result in a solid with maximum volume. So volume, my apologies if I'm keeping my color coding. Blue is supposed to be my helper. Green is going to be what I try to maximize. So volume equals length times width times height. All right, well, it told me that this was supposed to have a square base. So I'll call those x and x, and I'll call this y, which means that my volume is going to be equal to x times y, or volume equals x squared y. So this is what I need to do the calculus on because I want to find the maximum volume. Well, I'm going to use my surface area of 337.5. The surface area is going to be adding up all of the different faces. So I've got this face down here, which is x squared. I've got another one of those on the top, so that's 2x squared. And then I've got these rectangles, and each one of those rectangles is going to be x times y, and I have 4 of them, so plus 4xy. Well, this is what I want to take the derivative of, but I have 2 variables that my volume is dependent on, so I'm going to go ahead and solve for y. So if I solve this for y, I'm going to get 337.5 minus 2x squared all over 4x is equal to y. So I can go ahead and put that into my volume equation. And I'm going to do a little bit of cleanup work before I go to take the derivative, just so I don't have to do a product and quotient rule. So when I multiply this out, I'm going to end up with 337.5 over 4, and I still had an x, minus, this is going to end up being 1/2, because the 2 and the 4. This would have just been x, but then times x squared is going to end up being 1/2 x cubed. So taking the derivative, I end up with just this coefficient, 337.5 over 4 minus 3/2 x squared. This won't ever be equal to 0 because, won't ever be equal to, will not ever be undefined because I never have anything on the bottom that's going to cause me a problem. So this will be 337.5 over 4 minus 3/2 x squared. I can add the 3/2 x squared to the other side. Multiplying, taking square roots, I end up with x equals plus or minus 7.5. Well, a negative dimension wouldn't make sense here. So I'm going to start with 0. I'm going to plot that 7.5. And I end up with this being a positive and a negative for volume prime. I could have done a second derivative test, right? This right here would not be that bad to take the second derivative of. So I'm going to end up, this goes to 0. This 2 is going to swing down. I end up with negative 3x is equal to v double prime, which means v double prime of my 7.5 is going to come back less than 0. So I have a relative maximum. So going back then, I just found out that my x value was supposed to be equal to 7.5, but this said I needed dimensions. So I'm going to plug x right back into here, and I end up with y is also equal to 7.5. Not surprisingly, the one with the maximum volume ends up being x times x times x, which is a cube. All those square faces coming at you. All right, maximum area. A Norman window is constructed by adjoining a semicircle to the top of an ordinary rectangular window. Find the dimensions of a Norman window of maximum area when the perimeter is 16 feet. So my helper is going to be the fact that my perimeter is supposed to be 16 feet, but I'm trying to find the maximum area. Well, the area of this window is going to be x times y plus half of a circle, so half pi r squared. All right, well, looking at this perimeter is going to be x plus y plus y. Plus, I need to find the perimeter of this. Well, this is half of a circle, so it's going to be half 2 pi. And based on this picture, if this is x, then my radius is half of x. So 2 pi times r, okay, circumference. So P then equals, I've got x, I've got 2y, this half and this 2 cancels out. I've got half of a pi x. Oh, and I can change, sorry, this perimeter should be equal to 16. All right, so thinking about my area has a lot of variables going on. First thing I'm going to do is change that r to the 1/2 x from my picture. Then I'm going to work to solve for y so that I can substitute that in. Did I solve for y in this one in my answer key? I want to be consistent with what I did. I did. Okay. You also could have solved for x if you want to, but I just want to go with what I had on the paper before. So here I want to solve for y. So I'm going to take 16 minus x minus half pi x equals y. I'm going to divide the whole thing by 2. All right. Well, if I divide each of those things by 2, I'm going to end up with 8 minus a half x minus a 4th pi x is equal to y. So coming over here to my area, times all that stuff, plus 1/2 pi, and then we said we subbed in my r to be half of x squared. I just covered up that x, but hopefully you can still see it. This is going to be 8 minus 1/2 x minus 1/4 pi x. All right, we're going to simplify as much as possible before I go to take the derivative. So I'm going to end up with 8 pi minus half pi x minus oh no. Start again. This is where I wish I was in class. You guys could have called me out for my mathematical nonsense. That should have been an x. So this is 8x, and this is 1/2 x squared minus 1/4 pi x squared plus 1/2 times 1/2 squared is going to be 1/8 pi x squared. All right, so my area prime is going to be 8 minus x, because the 2 is going to swing down, minus 1/2 pi x plus 1/4 pi x. And this is where, ooh, I just moved the whole recording window. This is where a lot of people got confused on my answer key, because I'm trying to set this thing equal to 0 and solve for x. So what I'm going to do is I'm going to take out a negative x from each one of these things. If I take a negative x out of here, I'm left with a 1. If I take a negative x out of here, I'm left with a pi over 2. And if I take a negative x out of here, I'm left with a minus pi over 4. So if I think about adding these things together, 0 equals 8 minus x. These two can combine to become just a positive pi over 4. So now when I want to solve for x, I'm going to subtract the 8 to the other side. And if you had switched to decimals by now, that's fine, but we want to try to work with exact answers as much as possible. Divide by the negative, divide by this 1 plus pi over 4. So this is 8 over 1 plus pi over 4 is equal to x. When you do put that on a number line, you end up with a change from positive to negative, which is what we want because we wanted to maximize this area of the glass. Your textbook went through and they multiplied this whole x by 4 over 4, and said 32 4 plus pi was equal to x. And that's totally fine. If you want to go back and then find the y value, I think I put in my answer key. It's annoying, but definitely possible. You could take this x value and you'd sub it right in there, and you'd end up getting that your y value is equal to 16, that's a 6, 16 over 4 plus pi. Okay, so that one's just a lot of carrying through. The biggest thing here, again, that I know people got stuck on is how I went from this green step to the purple step, and all I did was say all of these things have an x in common so I can factor it out. Don't let the algebra part be the reason that your calculus gets more difficult. All right, that should be it for optimization videos. You have your group quiz coming up soon.